In this video, I will show you how to integrate quotients using natural logs. So first of all, here is a rule that you simply have to memorize. The integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. So keeping that in mind, here comes a u-substitution that you could really do in your head. I'm going to show it for instructional purposes, but feel free to skip this step. We will let u equal the whole denominator. So u equals x minus 5. And this feels silly because u prime is simply equal to 1. So nothing really changes when we rewrite the integral as 1 over u. Instead of dx, we can simply write du. We would normally write du divided by u prime, but u prime is just 1. Now we can use the rule that I just showed you. So the integral of this would be natural log of the absolute value of u plus c. But then u was x minus 5, so this becomes the natural log of x minus 5 plus c. For the sake of speed, I want you to consider trying to do problems like this in your head. When you look at it, you think to yourself, okay, u-substitution. We're going to let the denominator be u. But then you think to yourself, what is u prime? And you realize that u prime is 1. As soon as you see that u prime is 1, you should feel silly actually doing the u-substitution. You should just say to yourself, okay, fine. The denominator is u. So that means I'm going to have the natural log of u plus c. And of course, u is x minus 5. Because the derivative of u prime, was just 1, nothing else really changes. Quick side lesson. You should be able to do problems like this in your head as well. So we would let the denominator equal u. So in your head, think to yourself, okay, u is 2x plus 5. So what would u prime be? U prime will be 2. Notice how that is just a constant. So we will wind up dividing by 2 because we always divide by u prime. So that's just going to cause a 1/2 to show up in the front. The rest of the problem is easily done in your head because you have 1 over u. So you know the derivative of, the integral of 1 over u is natural log u plus c. And of course the u was 2x plus 5. So the bottom line is if u prime is either 1 or a constant, go ahead and try to do it in your head. As we begin number 8, let's think about why we are choosing natural log as a strategy. There are other strategies, but we will often use natural log when the degree of the denominator is 1 more than the degree of the numerator. So that's the case here, so let's go for natural log. So u-substitution, we will let u equal the entire denominator of 5 minus x to the 3rd power. So that means u prime will equal negative 3x squared. So let's do the u-substitution. And we have x squared over u. We replace dx with du over u prime. In other words, du over negative 3x squared. The x squared in the numerator will cancel out the x squared in the denominator. The negative 3 in the denominator will end up as a negative 1/3 out in the front. So now we have the integral, the negative 1/3 times the integral of 1 over u du. We have memorized that this integral is the natural log of u, well, the absolute value of u, plus c. We still have the negative 1/3 in the front, and u was 5 minus x to the third power. Kabam! For number 12, we will not use natural log. Notice that the degree of the numerator is higher than the denominator. So that makes us think probably not natural log. Also, we have a monomial in the denominator, just one term. Don't forget about the a plus b over c rule. We can rewrite this as a over c plus b over c. So I'm going to do that now. So this will be the integral of x to the third power over x squared minus 8x over x squared dx. Let's simplify each fraction. So the first fraction simplifies to x. I see these x's will cancel each other out, so I have 8 over x dx. Before I integrate, I'm going to rewrite one little thing and put 8x to the negative 1 power. No, I'm not going to do that. 8 over x is the same thing as 8 times 1 over x. Okay, so we will have natural log happening after all, eventually. Okay, so let's keep going. Integrating this term by term, we will have x squared times 1/2. All right, that's the power rule of integration at work. And then I see the constant, so I'm just going to keep the constant. And we have memorized that the integral of 1 over x is the natural log of the absolute value of x. And don't forget the constant of integration. So this is the final answer. When you see that the degree of the numerator is greater than the degree of the denominator, but yet you don't have a monomial, you should be thinking, okay, we're probably going to have to do long division. So I'm going to take that denominator and divide it into the numerator. So I have 2x squared plus 7x minus 3. So I look at the first terms and I ask myself, x times what will give me 2x squared? And the answer to that is 2x. So I'm going to put a 2x up at the top. Now I take my 2x and I do the distributive property. So 2x times x is 2x squared. And 2x times negative 2 is negative 4x. Then you subtract. 2x squared minus 2x squared is 0. These will always cancel out. Then 7x minus negative 4x is 7x plus 4x, which is 11x. And bring down your minus 3. Then you sort of start over. So x times what is 11x? So that's going to be 11. Take your 11 and do the distributive property. So 11 times x is 11x, and 11 times negative 2 is negative 22. And again, you subtract. So 11x minus 11x is 0. Negative 3 minus negative 22 is negative 3 plus 22, which is 19. 19 is the remainder. So what you do with the remainder is you add it on to the end as a fraction. You do 19 over the divisor. So 19 over x minus 2. So the original quotient is the same as what we're getting right here. So I'm going to rewrite my integral using all of this. So now I take the integral term by term. The integral of 2x is going to be 2x squared divided by 2. those 2's are going to cancel each other out. So I just have x squared. The integral of 11 is 11x. Now for the fun part. So the 19 in the numerator, I'm just going to put that in the front. So really I'm looking at the rest of this as 1 over x minus 2. So I'm looking at it this way. So I brought down the 19, and now I'm going to integrate 1 over x minus 2. So this is going to be natural log. Technically I'm doing u-substitution, but if u is x minus 2, u prime is 1. So I should be able to do this mentally. So fine, this is 1 over u. So that means the integral is going to be the natural log of u plus c. And u was x minus 2. So I just put natural log x minus 2. And that's it. For number 20, I once again see that the degree of the numerator is greater than the denominator. So I'm going to set up my long division. Here we go. X squared times what is x to the third power? That'll be x. I like to line up these like terms, by the way. So I take this x and I do the distributive property. So x times x squared will be x to the third power. And x times negative 5 is negative 5x, again with the like terms. Now I will subtract this. These will cancel each other out. I'm going to just bring down my negative 4x squared, which has no like term to combine with. Negative 4x minus negative 5x is really negative 4x plus 5x. So this is going to be positive x. And then I bring down the plus 20, and I start over. So x squared times what will be negative 4x squared? Well, that's negative 4. Take your negative 4 and do the distributive property. So negative 4 times x squared is negative 4x squared. Negative 4 times negative 5 is positive 20. And then you subtract. So these cancel each other out. No like terms here, so I just bring down the x. 20 minus 20 is 0. So I just have x. This is going to be the remainder because the degree here is less than the degree of what I'm dividing by. So I'm going to go ahead and write this as a remainder, and we put the remainder over the divisor. So I have x over x squared minus 5. So this is what I will use to replace my original integrand. So the original problem can be rewritten this way. Now I will integrate term by term. The integral of x is x squared times 1/2. The integral of negative 4 is negative 4x. Let me slow down. So I'm using some u-substitution here. Maybe I'll just do this sort of off to the side. So I have x over x squared minus 5. And I'm working my u-substitution. Let's let u equal x squared minus 5. And then u prime will be 2x. So if I do the substitution, I end up with x. Maybe I should put the integrals on here. So I'm doing the integral of this dx. So then I will have the integral of x over u. And then instead of dx, I will write du over u prime, which is 2x. We have the x in the numerator and the x in the denominator, so these will cancel each other out. And the 2 will end up in the front as a 1/2. So I have 1/2 times the integral of 1 over u du. I think I will now take this and jump back to the original problem because we're ready. So I have the 1/2. The integral of 1 over u is the natural log of u plus c. Remember that u was x squared minus 5. So I will have x squared minus 5. Number 24 looks pretty strange. Let's just jump into the u-substitution and see what happens. I see this 1 plus x to the 1/3 power on the inside, so let's let u equal 1 plus x to the 1/3 power. In that case, u prime will equal 1/3 times x to the, I'm subtracting 3 over 3, so this will be negative 2/3 power. Performing the u-substitution, I have 1 over x to the 2/3 power, and here it's time for the u, and I will multiply. Hold on, this is too big of a fraction bar. I'm going to multiply by du. All right, I replace dx with du, but I always do du over u prime. And u prime is this 1/3 x to the negative 2/3 power. Let me deal with this 1/3. When you divide by a fraction, you multiply by the reciprocal. So this is going to end up as a 3 in the numerator, which will be a 3 out in the front. So this is gone now. So focus on x to the 2/3 power times x to the negative 2/3 power. When you multiply variables, you add the exponents. But these exponents cancel each other out. So the x is gone. So now we just have 1 over u du. So we know that the integral of 1 over u is the natural log of the absolute value of u plus c. U was 1 plus x to the 1/3 power. So this gives us 3 times the natural log of 1 plus x to the 1/3 power plus c. Number 28 is ugly and strange, so be emotionally prepared. Let's jump right into the u-substitution. We will let u equal the entire denominator. So 1 plus the square root of 3x. Now, how about u prime? The derivative of 1 is 0, so that's gone. I'm going to think of this as 3x to the 1/2 power. Don't forget about the chain rule, but the derivative of the outer function is 1/2, and then we have the 3x to the negative 1/2 power. But then we need to multiply by the derivative of the inner part. So the derivative of 3x is 3, so we need to multiply by 3. I think I will rather put this 3 in the front with the 1/2, so the 3 is going to kind of go here. So this is u prime. Let's go ahead and do the substitution. So we now have 1 over u. We replace dx with du divided by u prime. So we have our 3/2 3x to the negative 1/2 power. Okay, the 3 over 2 in the denominator. When you divide by a fraction, you multiply by the reciprocal. So this will end up as a 2/3 out in the front. Next, I see this 3x to the negative 1/2 power. We know that when you have a negative exponent, you can bring that up to the numerator, and it'll be a positive exponent. So I'm going to go ahead and bring this 3x up to the numerator with a positive 1/2 power. And we have the du. We see that all of the x's did not cancel out. So this is no good. Somehow we need to get rid of the x's. Usually when this happens, we look back at the original expression for u, and see if we can sort of rewrite this in a way that allows us to substitute for x. Here's the trick. If I were to subtract 1 from both sides of this equation, I end up with u minus 1 is equal to radical 3x. And you know that radical 3x is the same as 3x to the 1/2 power. So I'm going to write it that way to make it more obvious the substitution I'm about to do. 3x to the 1/2 power can be replaced by u minus 1. So I'm going to take this 3x to the 1/2 power and write u minus 1 instead. So now we have this. I can do my a plus b over c rule and separate this into two fractions. So I have my 2/3 and the integral of u over u is actually 1. And then I have minus 1 over u. I see that natural log coming, don't you? And then I have du. So let's integrate this term by term. We have the 2/3 out in the front, and then we have the integral of 1 will be u, and the integral of 1 over u is the natural log of u plus c. I'm going to go ahead and put the plus c out here. Let's substitute the original expression back in for u. So we have 2/3 and then 1 plus the square root of 3x. 1 plus square root of 3x minus the natural log of 1 plus radical 3x. Plus c. So this is pretty ugly, but that is the answer.